Okay, so we will be looking at some of the problems related to dual cycle. So dual cycle in the numerical, it could be mentioned the cycle is dual cycle. It could be mentioned that the given cycle is limited pressure cycle, or it may be mentioned that the given cycle is the mixed cycle. So from here, limited pressure cycle will also be dual cycle. That you have to remember. So if you see the formula list, it has been given here PV diagram. This is pressure versus volume. This is temperature versus entropy diagram. So on the PV diagram, 1 to 2 process is isentropic compression. 2 to 3 process is constant volume heat addition. 3 to 4 process is constant pressure heat addition. And 4 to 1 process is isentropic expansion. So here you can see expansion means volume increases. And here you can imagine that this at point 1 here at this location piston will be there, and at this point 2 piston will be there. So when the piston is at point 1, what is the volume? Volume is V1, and what is V1? It will be this volume. This volume is the stroke volume, and this volume is clearance volume. So V1 will be Vs plus Vc, whereas when the piston reaches at point 2, this location, so the volume will be Vc, or you can say V2. So that is there. Then if you observe the TH diagram 1 to 2, here you can see entropy remains constant. So it is isentropic compression. When it is isentropic compression, you can observe temperature increases because of compression, but entropy remains constant. Then here you just observe constant volume curve is steeper, constant pressure curve is less steeper. So first we have constant pressure heat addition till here, and then we have first we have constant volume heat addition, and then we have constant pressure heat addition. Then isentropic expansion, the temperature decreases, and then we have uh, constant volume heat rejection process. Again, then we will have uh, isentropic compression and the cycle will continue. So here, what is the assumption? Assumption is during the heat addition process, there is no combustion. We are using source, external source. Like if there is a piston cylinder arrangement here, we will be adding source, and source will be transferring heat at constant volume and constant pressure. Same way, heat rejection, how it occurs, will be applying a sink over here so that the system can transfer heat to the sink. Okay, there will not be actually heat transfer because of the combustion in case of this process, because this is ideal process, air standard. And if you see the cycle, it is in closed loop. So basically, whatever air is there inside the system, it is not going to move in or it is not going to move out. Simply the whatever air is there inside, it will be the pistons will be reciprocating inside, and we will be having this cycle. Now here you can see we have defined few terminologies. First one is compression ratio, which is V1 by V2. So you can note this down in your book. Anyways, it is there in the formula list. Then here you can see cutoff as a percentage of swept. This we had seen in the diesel cycle also, and this equation also we had derived there. So X is cutoff ratio rho minus 1 upon compression ratio RC minus 1. Then we have expansion ratio, which is volume after expansion V5 to the volume before expansion, which is V4. Then next equation is cutoff ratio. Cutoff ratio is V4 by V3. So it is usually for constant pressure process. Uh, volume where the cutoff occurs to the volume V3 where the fuel injection starts at constant pressure process. Okay, so that is called cutoff ratio. Then we have relation between expansion ratio, compression ratio, and cutoff ratio. If you see equation 6 and 7, equation 6 is for isentropic process. So just observe process 1 to 2 is isentropic and process 4 to 5 is isentropic. So 1, 2 and 4, 5. So here you can see these are for 1, 2 and this is for 4, 5. These equations are there. And next you can see equation 7. These equations are for constant volume, constant pressure and constant volume process. So 2 to 3, 3 to 4 and 5 to 1. So these equations will be available over here. These are the three equations for three processes. And then heat addition. So here you can see heat addition is heat addition at constant volume plus heat addition at, or you can say Q supplied at constant pressure Since this is small q, this is specific heat added. So for constant volume, it will be Cv, higher temperature. So Cv, higher temperature is T3, lower temperature is T2. For constant pressure heat addition, it will be Cp, T4 minus T3. And for QR, small qr, it will be again constant volume is there. So Cv, T5 minus T1. So those equations are mentioned over here. These are the equation. You can check the unit kilojoule per kg. Then pressure ratio, Rp, mean effective pressure, all these equations are given, and these equation we derived efficiency of dual cycle 1 minus 1 upon Rc raised to gamma minus 1 in bracket Rp rho raised to gamma minus 1 divided by Rp minus 1 plus gamma Rp in bracket rho minus 1. Okay, so with this, we will be now moving on to a numerical. So just a minute. Wait. I'm just doing some setting. Huh. So we will be solving this question. You can write down in your notebook December 18, 6C, 10 marks. So this will be the numerical which we are going to solve. Okay, so what we will do, we will write down all the equations which we had seen before. So uh, in the formula list, all the equations are given. So I'll quickly note down few of the equations. First, we have written Rp, which is pressure ratio. On the right side, here we have written the pressure ratio equation. I've already drawn here PV and TS diagram of dual cycle. So next one is compression ratio. Compression ratio RC equation is V1 by V2. Then next equation, equation of X is equal to cutoff ratio minus 1 divided by compression ratio minus 1. Then next we have expansion ratio RE, which is V5 by V4. Okay, and then we have cutoff ratio rho, which is V4 by V3. And then we have relation between RE, RC, and cutoff ratio. So basically, RE is RC by rho. So we have written all the equations which we might require in the problem. Now we'll go through the question. What is given in the question? Are you able to see my screen? Huh. So in an air standard dual cycle. So from here we understand the cycle is dual cycle. It could be written here mixed cycle or limited pressure cycle. All are same. Okay. So pressure and temperature are zero point 0.1 megapascal and 27 degrees Celsius. So what I'll write down the given data. You don't have to note down these things. I'll be sharing PDF. So just you pay attention and understand the things. Okay. So it is mentioned here pressure and temperature. Two values are given. What are these values? 0.1 megapascal and 27 degrees Celsius. So we will mention this. It is usually at zero point 0.1. Okay, so this I'll write down the data. P1 is equal to 0.1 megapascal, 0.1 megapascal to kilopascal. So it will be into 1000, so 100 kilopascal. And temperature T1 is given as 27 degrees Celsius. So 27 plus 273, it will be 300 Kelvin. Next data we will see in the question. The compression ratio is 18. Now compression ratio means RC has been given. So I'll write down compression ratio is RC and RC is given as 18. Now this RC can be V1 by V2, or I can even write specific volume at 1 divided by specific volume or at 2. Whatever is required we can use. Okay, either we can use volume at point 1 means this point by volume at point 2, or I can write specific volume at point 1 divided by specific volume at point 2. So any equation I can use. It depends on the on what we have to find. So that I have written. Next, if you see the given data, the pressure ratio for constant volume part of heating process is 1.5. So P3 by P2 has been given, RP. It is 1.5. So RP is 1.5 and it is P3 by P2. This data has been given. So I'll write here given. Next data, volume ratio for constant pressure part of the heating. So constant pressure part volume ratio is what? V4 by V3. And what is V4 by V3? V4 by V3 is cutoff ratio. So basically cutoff ratio has been given. I'll write down rho, which is cutoff ratio, which is V4 by V3. It is given as 1.2. So now we can start with the solution. Okay, this is the given data. Now what has been asked? See the first question, what is asked? We have to determine thermal efficiency. And second one is we have to determine mean effective pressure. So what we are going to do first, we will write down the equation of efficiency of dual cycle. So first one, efficiency dual we have to find. So I'll write down the equation efficiency of dual cycle is equal to 1 minus 1 upon RC raised to gamma minus 1 in bracket RP rho raised to gamma minus 1 upon RP minus 1 plus gamma RP rho minus 1 bracket complete. Main bracket should be completed. Now substitute all the values. We have all the values. So 1 minus 1 upon RC compression ratio, it is given as 18. So 1 minus 18 raised to gamma minus 1. Gamma for air is 1.4. So you have to assume this value. Like if you want, you can note it down here. Assume gamma equal to 1.4 for air. In bracket, RP is given in the question. RP is 1.5. So I will substitute value 1.5 into cutoff ratio rho. So cutoff ratio is 1.2. So into 1.2 raised to gamma, which is 1.4 minus 1 divided by RP 1.5 minus 1 plus gamma 1.4 into RP 1.5 in bracket rho. Cutoff ratio is 1.2 minus 1. So from here I will get efficiency of dual cycle. It is 0.6797, and if you multiply by 100, so I can write it is 67.97 percentage efficiency of dual cycle. So this will be first answer. Let me know if there are any doubts. Anyone is having any doubt? Hello? Okay. Okay. Next we will see the second part of the problem, which is mean effective pressure, and that you have to find in megapascal. Now you have to be careful. See, usually if I find mean effective pressure, we use the units in thermodynamics in kilopascal. It has been asked in megapascal, so don't forget to divide by 1000. Otherwise, there some marks will be deducted. Okay, so I'll write down the second heading, mean effective pressure. mean effective pressure. Okay, now what do you mean by mean effective pressure? If you observe pressure versus volume diagram, and if you see the cycle, it is in clockwise direction 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 1. Just see the arrows, it is in clockwise direction. So basically, dual cycle is a power producing cycle, and whatever area is enclosed in this cycle on PV diagram, what is that? It is W net. And since this is power producing cycle, this W net will be positive. Same way on TS diagram, temperature versus entropy diagram, if you see this cycle, it is clockwise direction. Okay, if it is on one cycle, if the cycle is in clockwise direction on one diagram, other diagram also it will be in clockwise direction. So again, if this is in clockwise direction, whatever the area enclosed over here on TS diagram, it is Q net. Okay, and according to and this Q net will also be positive. And according to first law of thermodynamics for a cycle, W net is Q net. So basically, these two area we can say they are same. Now, what is the concept of mean effective pressure? So basically, mean effective pressure is a pressure like this. So if I take this, this is mean effective pressure. Whatever area is enclosed by mean effective pressure, okay, this area will give me W net. And what is the change in volume over here? Here you can see this volume is 1, this volume is 2. So what I can write, W net is area under the curve. So W net, what will be area? Height of this rectangle, which is mean effective pressure, into length of this rectangle, which is V1 till here minus V2. So I can write V1 minus V2. But this will be small v because I am writing here small w. So this what I can change, mean effective pressure will be equal to W net upon V1 minus V2. What is W net? W net is Q net. So Q net upon V1 minus V2. Or I can write what is equation of efficiency? Efficiency is output, which is W net, upon input, which is heat supplied. Okay. So what I can write here, instead of W net, I can write in this equation, instead of W net, I can write QS into efficiency. Okay. So if I check this, mean effective pressure, it will be QS into efficiency divided by V1 minus V2. So basically, I'm going to use this equation. Am I clear in explanation? Hello. Huh.
Yes, sir.
So mean effective pressure, I will straight away write down the equation. Efficiency of dual cycle into QS divided by Vs. Or Vs is what? Vs is V1 minus V2. I can write this. Now next part, we have already found efficiency of dual cycle in the first step. So we have the value of efficiency that we have to write down in decimal. So first part is there. We need value of QS, we need value of V1, we need value of V2. These values we don't have. So one by one we are going to find all the values. First what we will do, we will start with V1. Okay, so I'll write down calculation of V1. This is required. So how I can find V1? I know this equation P1 V1 equal to MR T1. Okay, so P1 V1 upon M is equal to RT1. What is V1 upon M? It is small v, specific volume. So P1 small v1 equal to RT1. So from here I can write V1 equal to RT1 by T1. So just substitute the values. What is value of R for air? Characteristic gas constant 0.287 kilojoule per kg Kelvin into T1 is given in the question. It is 300 Kelvin. So 300 divided by P1. It was 100 kilopascal. So from here I can get this value of small v1, 0.861 meter cube per kg. So we have now found value of v1 in this equation. So in this equation we have efficiency of dual cycle, we have v1 value. Now we require to find v2 value and qs value. So we will write down calculation of v2 value. Calculation of v2. So how we can find v2? So simple calculation will be there. If you see the given data, compression ratio RC is v1 by v2 or small v1 by small v2. This is capital V1 by capital V2. The unit of capital V1 will be meter cube. Same way, capital V2 will be meter cube. Whereas if you see small v1 and small v2, it will be meter cube per kg, specific volume. Okay, so we already have RC value. We have found V1 value just now. So I can find what is V2. So I'll write down the equation. V2, sorry, RC, sorry, compression ratio RC is V1 by V2. So what I can write, what is V2? V2 is V1 by compression ratio. What is V1? V1 just now we calculated. V1 value is 0.861 and compression ratio is 18. So just calculate this, we will get V2 as 0.0478 meter cube per kg. Now, if you see the main equation of mean effective pressure, we have dual efficiency, dual cycle thermal efficiency. We have specific volume of zero point 0.1 and now we have specific volume of 0.2. What is remaining now? We have to find QS. Once I find QS, I can find mean effective pressure. Okay, so what I'll do now, next, I will write down equation of QS. I'll write down calculation of QS. Now, if you can recall, heat is added at first at constant volume and then at constant pressure. So constant volume heat addition is there and then constant pressure heat addition is there. So what will be heat addition at constant volume? So first, let me write down the equation. QS will be equal to QSV, heat added supplied at constant volume, plus heat supplied at constant pressure. So heat supplied at constant volume will be CV delta T. So CV and delta T, for delta T we will see TH diagram. So 2 to 3 process, T3 is higher, T2 is lower. So T3 minus T2. CV T3 minus T2 plus heat added at heat supplied at constant pressure. It is at constant pressure, so I will write Cp delta T. And delta T we need to check from TH diagram. What is delta T? So if you see the TH diagram, process 3 to 4 is heat supplied at constant pressure. So 3 to 4. And if you see here, T4 is higher and T3 is lower. So I'll write down T4 minus T3. T4 minus T3. Now simply substitute the values. CV value. Uh, Before that, if you see CV and CP value, we have this we can assume CV and CP for air. Okay. We don't have value of T2, T3, T4. So we need to find all the temperatures first. So what I can write, I can consider process 1 to 2. This process 1 to 2. It is isentropic process. So what I can write, T2 by T1 is equal to V1 by V2 raised to gamma minus 1 and V1 by V2 is RC. I'll write down the equation. Consider process 1 to 2 which is isentropic. So what I can write, isentropic compression. What I can write, I can write T2 by T1 is equal to V1 by V2 raised to gamma minus 1. What is V1 by V2? V1 by V2 is RC. So RC raised to gamma minus 1. Okay, so from here I can write down T2 is equal to T1 into RC raised to gamma minus 1. So T2 is equal to, what is T1? 300 Kelvin into RC is 18. Gamma for air is 1.4 minus 1. So if I find this value of T2, it comes out to be 953.3 Kelvin. So we have now this value of T2. Okay, so if you see this equation, we got T2. Next, what we want is T3. Okay, and then we will calculate T4. So in order to calculate T3, again we will go to PV and TH diagram and understand. So if you see PV diagram, point 3 is either in constant volume process, you can take it in constant volume process or constant pressure process. But since we know T2, we will be considering which process? Constant volume process. So I'll write down consider process 223, which is constant volume process. Consider process 223, which is volume equal to constant heat addition. Okay, so what I can write, process number is 223. So I can write P2 V2 by T2 equal to P3 V3 by T3. Now volume is constant, so I will cancel the volume part. What equation I am going to get? I will get, uh, just I'll rearrange the terms. So I'll get P3 by P2. So P3 is over here, I will take P2 over here. So P3 by P2 and T3 will go on this side. So T3 by T2 equal to T3 by T2. And what is P3 by P2? Can anyone recall what is P3 by P2? No, not expansion ratio, it is pressure ratio. So if you see, I had written here RP is pressure ratio P3 by P2 and RP value is given in the question. RP value is how much? 1.5. So simply this value will be equal to, wait a minute, this will be equal to RP and RP is 1.5. So what I can write, T3 will be equal to RP times T2. RP is 1.5 and T2 we have already found out 953.3. So from here, what is value of T3? We are getting T3 as 1429.95 Kelvin. So if you see the main equation of mean effective pressure, sorry, if you see the equation of heat addition, now we have found the value of T3 also. So this T3 has been calculated, here also T3 has been calculated. Now only one unknown is there, which is T4. So again, what we can do, we can go to the PV or PV and TH diagram. Point 4 is in 3 to 4 process and 4 to 5 process. But we don't have data of point 5. We have T3 value. Okay, so what I will consider constant volume heat addition process. Sorry, this is constant pressure heat addition process. So I'll write down consider process 3 to 4. So consider process 3 to 4, which is pressure equal to constant heat addition, heat supplied. So what I can write, since it is constant pressure process, I can write down this type of equation and the number is 3 to 4. So P3 V3 by T3 equal to P4 V4 by T4. Since pressure is constant, I will cancel pressure on both sides and I will get this equation. Now again, I'll rearrange the terms. If you see here, we are getting V4 and V3. And if you can recall V4 and V3, just see the PV diagram. V4 and V3. This is which ratio? If you consider V4 by V3, it is cutoff ratio. And that cutoff ratio has been given in question. What is the value of cutoff ratio? 1.2. So I'll write down V4 by V3. So I've taken this V4 is kept here and V3 I've taken here. So V4 by V3 is what? Cutoff ratio. And this will be equal to, in terms of temperature, it will become T4. I will take T4 over here. So T4 by T3. T4 by T3. I want to find T4. So what will be T4? T4 will be equal to T3 into cutoff ratio. So T3 value here we have found out. T3 is 1429.95. I'll write down 1429.95 into cutoff ratio value is 1.2. So from here we can find T4 value. T4 value comes out to be 1715.94 Kelvin. So if you see the heat transfer equation, heat supplied equation, we have found all the temperatures. Now this T4 is also calculated. So I can find value of QS. Okay, so I'll write down QS is equal to CV. Simply I'll copy this equation. Wait. So QS, this equation is there. Okay, so just substitute the value. CV for air is 0.718 kilojoules per kg Kelvin. T3 value, T3 value here you can see it is 1429.95. 1429.95 minus T2. T2 value is 953.3. 953.3 plus Cp is for air 1.005 kilojoule per kg Kelvin in bracket. T4 value we just now calculated 1715.94 minus T3 value 1429.95 bracket complete. So if I find QS value, QS comes out to be 629.65 kilojoule per kg. Now, if you see the main equation, we are supposed to find mean effective pressure. So in mean effective pressure, now we have QS also. So in equation of mean effective pressure, dual cycle efficiency, thermal efficiency is there, QS is there, V1 is there, V2 is there. Substitute all the values and we can get the answer. So I'll substitute over here only efficiency of dual cycle. First value, it is this one, 0.6797. 0.6797 into QS value. QS value is 629.65. 629.65 divided by V1, small v1 we have found over here. So it is 0.861 minus small v2, specific volume of zero point 0.2. Here we have found 0.0478. 0.0478 kilojoule, meter cube per kg. So from here I can find mean effective pressure. Mean effective pressure comes out to be 526.28 kilopascal. But if you can recall in the question, mean effective pressure has been asked in megapascal. So I need to divide it by 1000. So if I divide this value by 1000, I will get this value 0.526 megapascal. So this is the end of the question. Mean effective pressure is 0.526 megapascal. Now see, there is one more method by which we can find mean effective pressure. But for that, you need to remember the equation. So if I go back to the formula list of this dual cycle, here you can see we had used this equation, this type of equation, this equation we had used. Equation number 10, this equation we had used. So instead of this, we can even use this equation, but it is difficult to remember this equation. You can observe we have all the values. P1 was given in the question, compression ratio was given in the question, gamma for air you have to assume 1.4, pressure ratio was given in the question, okay, cutoff ratio rho was given in the question. So all values were there. If you can remember this equation, you will get mean effective pressure in single step. Okay, you don't have to find separately dual cycle efficiency, QS, V1, V2. Okay, simply you need to substitute all the values which we already had, and in one step we can get mean effective pressure answer. But the problem with this equation is very tricky. If you miss any bracket, here you can see this, here also bracket is there, here also bracket is there. If you miss any bracket, you won't get matched the answer. You won't be able to match. So the homework part will be I have solved the mean effective pressure by this equation. You will be solving mean effective pressure by this equation and try to see whatever answer you are getting here, it is matching with the answer which we have calculated. Is it clear? So this is the end of the problem of uh, problem on dual cycle.